We are continuing with the textbook questions. The first one, identify the functional group in the following compounds. So we need to figure out what the functional groups are in each of these. So CHO, it's obviously an aldehyde. The CHO group means it's an aldehyde. OH is an alcohol. OMe is an ether. Uh, Functional groups, we had done a video on the same. It's better to be thorough with that and then come on to this one. The next one, this is an amine group. This is an N-alkyl dialkyl ester. Sorry, alkyl amine ester, which basically means this nitrogen has carbon groups attached to it. Also, this is COO. That's why it is called an ester. Right. The last one is CHNO2. So you have, sorry, CH double bond CH, which means it's an alkene. And the NO2 means it's a nitro group. Which one of the two, CH2, CH2O minus or CH3, CH2O minus is expected to be more stable? Now we need to, first of all, the main difference between these two negatively charged ions is the fact that you have an NO2 over here, whereas over here you do not have the NO2. So NO2 is an electron withdrawing group, whereas CH3, CH2 are electron releasing groups. And because of that, CH3, CH2 will actually increase the amount of negative charge on the oxygen and it will destabilize. Whereas this NO2, CH2, O minus, this particular NO2 group is pulling the electrons towards itself and it will basically sort of stabilize the O minus. This has to do with the inductive effect. So inductive effects is to do with the plus I and minus I groups, which we had discussed in one of the previous videos. Explain why alkyl groups act as electron donors when attached to a pi system. The reason they act as electron donors is because of the effect hyperconjugation. So and these are called as this is also called as no bond resonance, which means they're here at this point. Actually, there has to be a positive charge. I'm so sorry here. So hydrogen gets a positive charge, and this in turn makes sure that there is a stability to the particular compound. Actually, here you're supposed to have a double bond. So more is the number of hyperconjugative structures, more is the stability. And that is why the alkyl groups, when they're attached to a pi system, they will automatically stabilize it. And one more thing, if these hydrogens were also alkyl structures, they would automatically have made the structures more. Oh, sorry, there is no hydrogen. It's only a CH. So that would automatically make the structure, if instead of this hydrogen, we had a CH3 group, that would again increase the number of resonance structures which are formed, and that would increase hyperconjugative structures which are formed, that would increase the stability. So the main reason you have the increase in stability by the alkyl group is due to the concept hyperconjugation. Last question in this video, what are electrophiles and nucleophiles? And explain with examples. So electrophiles are electron loving. So basically they are either positive or neutral species that have one electron or rather electron deficient. So H3O plus is positive, Cl plus is also positively charged. Whereas BF3 and AlCl3 are electron deficient because of their octet state not completely full. Notice we don't write examples for electrophiles as Na plus or Ca2 plus because their outermost shell or the octet is completely full. So we will not talk about such ions. Next are nucleophiles. Nucleophiles are negative or neutral species and they are electron rich. The way it is easy to remember electrophiles and nucleophiles and the differences and basically about them is electrophiles are electron loving and nucleophiles are nucleus loving. Since they're nucleus loving, nucleophiles have a negative or a neutral charge and they are electron rich, whereas electrophiles are electron deficient. So the examples of nucleophiles include NH3, ROR, Cn minus, and X minus. With that, we're done with the questions in this video. We will be continuing with the same in the next one.